This is the first of two pre-flights on atomic nuclear physics. This one is going to focus on alpha, beta, and gamma decays. I apologize in advance, but since I'm doing this on paint with a mouse instead of some pad to write on, the handwriting in here will be, well, pretty bad. But we'll manage. To start, we have to be able to identify a few features about the atomic system and the way that it's numbered and labeled. So we see three features here for carbon 14, a 14, a 6, and a C. Up here, this is called the atomic mass. It's the number of neutrons plus protons combined. Over here is the atomic number. The atomic number is unique for every single element. So carbon is the only element with 6 protons. Anything that has 6 protons must be carbon. If it has less than 6 or more than 6, it is no longer carbon and something else. We see here the C. This is the element's abbreviation, carbon. Sometimes you will get another symbol up here. For example, maybe we could do a +2. This tells us that it's an ion. In particular, we know that it has a charge of +2e. This means that it had to have lost 2 electrons. Protons don't move around as the electrons, so that's what that would come from. If it was -2e, it means it gained 2 electrons. Now that we know how the symbols are arranged and what all of the different numbers and letters mean, we can go ahead and do some decays. So we'll get rid of this, and we'll start with an alpha decay. Alpha decay. Alpha is that fish-like symbol that came out absolutely terrible here. That's a little better. Now the alpha decay means an alpha particle is emitted. An alpha particle is a helium nucleus. One of the most common types of alpha decays is carbon 14. It undergoes alpha decay. So we start with 14,6C for carbon 14. We have an arrow to indicate it's going to yield. It is going to yield an alpha particle. An alpha particle is a helium nucleus. So 42He. Helium has 2 protons, and since it's an alpha particle, it's also going to have 2 neutrons. Now there has to be something else that's yielded. We see the atomic mass before was 14. Helium only has an atomic mass of 4. That means there has to be an atomic mass of 10 somewhere else. The atomic number was 6. Helium's atomic number is 2. That means there has to be an atomic number of 4 for this other element. Now what we're going to do is, since we have an atomic number of 4, we'll go to the periodic table of elements. We will find the 4th element, beryllium, Be. Come back here, put in our element symbol, beryllium, and we're done. That's the alpha decay. Another quick note about alpha particles: they are ions. They have a charge of +2. They did not take the electrons with them. It's just the helium nucleus, which means beryllium is also going to be an ion after this nuclear reaction. Its charge will be -2 because it has the extra electrons that the helium nucleus did not take with it. The next type of decay is called beta decay. There's 2 types. There's beta positive and beta negative. For this video, I'm just going to focus on the beta negative. So a beta particle is a highly energetic electron. What we mean by highly energetic electron is a very, very fast moving electron. The speeds are fractions of the speed of light, talking about 5 to 10% the speed of light, so extremely fast. That makes them dangerous to humans. If you are exposed enough to beta decaying radioactive material, it can cause some long-term damage to you. One of the most famous types of beta decay is uranium-239. It undergoes beta decay. Beta decay itself, what we're going to have is an electron. So we have E for electron. Its atomic mass is 0. Electrons do have mass, but they are so small compared to neutrons and protons. In terms of our nuclear equations, we don't bother to put them in here. Its atomic number is -1. This leaves us with something else that has an atomic mass of 239. But this 92 has to equal 92 on the right side, so we have -1 plus 93. What has physically happened in the beta decay is a neutron has turned into a proton. In the process of doing this, it has ejected an electron. We go to the periodic table. 93 is neptunium, Np. There we go. Beta decay. Our last type of decay we're going to talk about is gamma decay. Gamma decay is the most energetic decay. It is the most dangerous to humans if they are exposed to it. And gamma decay gets its name gamma because it actually emits gamma rays. Uranium-235 does undergo gamma decay. What is physically happening is the nucleus is rearranging itself in some way due to its instability, and the process it emits a gamma ray. Quite often that gamma ray is absorbed by another surrounding nucleus, and then it will be re-emitted again. But however, some of it does escape, and what does escape is dangerous to human surrounding. Gamma is a form of light. So uranium-235 undergoes gamma decay. We put the gamma symbol. Gamma light has no mass, no charge, so nothing has changed. We actually still have uranium-235 as a result. What has happened to our nucleus is not as energetic as it was before, but it could very well absorb another gamma ray and become more energetic in the future. That's all I have for this video. Thank you for watching.